Hello, everyone. I hope you are doing well. I'm so happy to be here with another session with Microsoft Zero to Hero and in the great day. And before to jump and kick off the main session, let me share some information about the today's session and also our community. Today we have Leo here. He wants to talk about Power Platform and controlling developers in the Azure DevOps. It's a beautiful topic and title. And as you know, we are part of Microsoft Learn Community. Microsoft Learn Community is a central hub with a lot of learning content. You can choose your learning content based off your certification, based off your role. Also, you can ask your question from a lot of Learn expert. You can join aka.ms Microsoft Learn Community. And also, this is our calendar, February calendar. You can register for next two session from our channel, LinkedIn also, and also all previous session uploaded on our YouTube channel. You can watch more. And the last slide is our code of conduct. Be aware of other, be friendly and passionate, be welcoming and respectful, be open to all questions, viewpoint, be understanding on different, and be kind and consider to other in the chat, in the question. And now is the time to add Leo on the stage. Hello,
Hello,
how are you?
I'm fine. Looking forward to this.
Yeah, great, great.
How are you
Actually,
doing?
I'm fine. I'm fine. Thank you very much. I checked the title. Title it's very interesting for session. Is controlling developers, and it's very important. You can have a control on the developer on the DevOps because there are a lot of malicious code or other things you can control them.
Yes,
Great. You
indeed.
can.
I can start.
Yeah, sure.
Let's
Uh,
see if we can get everything to work.
uh,
Um, I think if I share this screen,
I add
then
your
you should
screen
all
to the
see it.
stage. Yeah, I see. Go ahead.
Okay, if everybody is the sound is okay and the screen is okay, then let's start. So welcome to the talk. You've got the Power Platform, controlling developers in Azure DevOps. So very quickly, who am I? I'm Leo Visser from the Netherlands. I'm a consultant at OGD, and I'm also the lead for automation and AI at the moment. You can find my blog on autosysops.com, and you can find me on the socials at autosysops. I'm also a Microsoft MVP. If you have any questions after the talk or later, feel free to contact me or ask them here. You can also put them in the comments below on the YouTube video. I will try to sometimes check if there's any questions and answer them. So, what are we going to do today? I'm going to propose you a little case, something I've seen. Then we're going to talk a little bit about the problem in this situation. I'm going to show you a solution. We're going to look at how to actually create the solution. And at the end, there's a small conclusion. I try to keep the questions at least until the end where possible. Feel free to post your questions in the chat. I'm keeping an eye on the chat. So if I see your question and I can answer it instantly during the talk, I will try to do this. And else, we will answer the questions at the end. With that being said, normally I would do this in a big room, so we would have a little show of hands. Not sure if we can do it here, but maybe you can say something in the chat if you are somebody who actually works with code regularly, because we have many different people attending these kind of talks, these kinds of sessions. So some of you might be working daily with code, some might mostly using the code, and some are just selling the code. So I'm going to talk about many different aspects of working with code, working with software. Some parts might be recognizable for some of you, and some parts might not be. So I will try to at least explain the basics of every aspect. So sometimes maybe I'm sorry, I'm explaining stuff you already know, but I hope it will help you to get a picture. So here's our newest AI startup. It's a small company with some developers and some salespeople. I like to also use some AI. So I asked my AI, well, can you create me a picture? And because I like Legos, I asked, well, let's make this one in Lego because why not? So on the left, you see clearly it's the developers, it's chaos, there's things everywhere. There is Windows, which is actually weird for the developers, but it can happen. And on the right, we have more of like the sales department. It's more structured, less of a chaos. I didn't ask AI to do this, but AI clearly knows what's up. Also, a fun thing, although AI seems to be getting better at making human hands, apparently it still has problems creating Lego hands. So it's clearly still adding fingers to Lego hands. Just a small tidbit I thought you might like. So like I said, on the left, we have the developers. Let's zoom in a little bit on what these developers are actually doing. So developers, they are working with code, and the code is often stored in what we call a repository. It's a place where they can all work together on this code and make sure that it's stored centrally. This code we often store at what we call the main branch. This is the place which is the production code. If it's in here, then the code is in production. There's many different ways to work with code. The most simplest version is when you want to create something new in the code, you branch off. So you make a copy of the existing code and you create what we call a feature branch. In here, you can do your development. You can create new functions, new features, whatever. And once you're done, you're going to push this code back to the main branch, but we do this with what we call a pull request. So this pull request, it will compare the differences between the feature branch and the main branch, and it will show these differences. And in the pull request, you can give some more information. And once this is accepted, the code is accepted in the main branch and a new version is created. Like I said, there's many different ways of working with code. For many software systems, we will use more complex versions of this. But in essence, at least we will always have these pull requests, either directly going to the main branch or in different situations. And these pull requests, they are being used in the system which is used to um, maintain the software and maintain the versions of the software. Now, on the other hand, we have the sales people. And if there's a new version, it's happy. We can maybe sell something more that the new version might have new features which some customers have been asking for. So now we can convert these customers to using our software instead of the competitor software. But oh, it shouldn't have done this. Sorry. If we have this new version, it also means that there's some work to do because we often have to update the license agreements. Either we are using new dependencies, new software in our software, which have to be added to the license, or maybe we need to add new licenses because often if we have software, we want to sell this as a service. So maybe these new features have to be added to certain licenses or new licenses need to be created. Also, if I want to really sell this well to my clients, I probably have to create some new demos. And in the end, we have to create new sales pitches. So the sales team, they have some work to do once this new version is created. This is why they're here. This is what they do. But we've come to a little problem. See, our AI startup, on the left hand, we have the developers, and they want to build it fast. They want to really quickly add new features, add as much as possible. And it also means that stuff is breaking often. But it doesn't matter that much, right? Because we're working in code, we can quickly push new versions, we can quickly push new updates. Everything is connected to the internet. So build it fast, break often. That's the mantra of many software developers. But on the right hand, we have the salespeople, and they need to spot everything. They need to make sure that everything is okay when talking about like the licensing agreements, when talking about how it's being paid. They need to make sure that the SLAs or XLAs or whatever they're using are in order. So if there's downtime in a program and people are using this in their production workloads, that these downtimes are not too long. And if they are, that there might be some penalties for this. And this takes time. They need to make sure that they don't make these mistakes, because if they do, it could cost a lot of money. If, for example, um, they say that a certain SLA, a certain service level agreement, accidentally has an extra 9 added for an uptime promise, and this isn't being reached, then it could cost them a lot of money. So they really need to be on the details. Now, we can make sure that at least these two teams can work quite well together, because if a new version is created, the software developers need to let this know to the sales department, and some things probably have to be done before the software can actually be pushed to production. The way I've often seen this being done is by using a pull request template. So I hope you can all see this. I can maybe try to zoom in a little bit. So in here, I've got a small repository. I've got my main branch, which has a README, and I've got my development branch, and the README is changed. So there's been some change done to this code. Also in here, I've got a little file called a pull request template. And what this means is, once I'm creating a pull request, so I'm creating a new pull request. Oh, let me quickly remove the other one. I thought I already removed it. Sorry for that. So when I'm creating a new pull request, it's showing the commits, it's showing what's changed. And also, instantly in the description, some information is being added. This is the information which is shown in here. So here I can give some text. I can give some checkboxes if I want. And they are being added to the description automatically. Here you also see the preview. So you actually see checkboxes. I can create this pull request. It will check if there's no merge conflicts, and it will give this description. This is something I've seen being used in many different systems. In many different organizations, I've seen this being used. A developer is creating some new release, and there's some checkboxes. And somebody has to check all the checkboxes, and when it's done, they can complete the pull request. This is nice, but say that there's some things which have to be done not by developers, but they have to be done by the salespeople, like making these new license agreements, like making demos, and so on. I don't know about your organizations, but if I ask in my organization to the salespeople, hey, could you maybe go to Azure DevOps and make sure that you check the box in the right pull request? They don't like me that much for that. They don't really like this program to work with. It's way too complicated, and also finding the right pull request can be difficult. So yeah, that's kind of a problem for us. So that led me to kind of come up with a solution. And the solution is built up by many different parts. But I decided, well, the Power Platform and mostly here Power Apps are a great way to build some interface to make my have this better for my salespeople and allow them to more easily control this workflow. So they can say that the stuff is done before it can actually be pushed to production. So before we go into the how, let's quickly see what it actually does. So in here, I've got a different repository. Again, we have a main branch, which has some files, and we've got a development branch, and there's some changes. Nothing special. And again, I'm going to create a pull request. This pull request, it has some changes again. You see there's no pull request template this time. There's just a small description from the commit message. I'm going to create it. And now you see something interesting. You see here, there's a Power Platform control check. And I can say set auto complete, but I can't actually complete it yet because this is blocking my completion. In here, I have a Power App. And once I'm going to refresh this Power App, you see that actually the pull request we just created has shown up here. I could add multiple checks or whatever. I could add a more complicated interface, but for now, it's my list. I've done my stuff and I can say it's okay. And once I go back to Azure DevOps, you see it now turns green. And now the complete button has appeared where I can actually complete the pull request. I'm not going to do this, but in essence, this is how it works. Or at least this is what it does. Now, let's dive into how it actually works. So this solution, it uses several different things. At the left, we're using Azure DevOps. At the right, we're using Power Apps, what you just saw. But in between, we're using Logic Apps, which is a service in Azure, which uses low-code automation to do some stuff. And I'm using a Dataverse to store some data. Now, there's many different ways to build this. I'm just showing one way to build this, and I will try to show how it's being built so you can do this in your own way. You could do this with some Azure functions, with code, with a SQL database instead of the Dataverse, maybe with a SharePoint list. There's many different ways of doing this. Let's first start by looking to the Dataverse. So here we are. In my environment, I've created a table which is called pull requests. And in here, oh, sorry. And in here, I've added several different columns. So there's the ID column, which is auto-generated. Then there's the approved, there's the pull request ID, and there's the pull request title. You see I've done this demo a couple of times already by now. And here now we see them all on yes. If I create another pull request because I abandoned the previous one, it will take a moment. And if we refresh this one, one more time, it's a process which takes a couple of seconds to run, and there's a lot of caching happening in here. But there's 2 additional rows. Yeah, it's added. So now we see that number 18 is there, which has a no. So it's not yet approved. So this is how our table is being set up. It's just a small table of data. To make sure that I can actually communicate to this table, I had to set up some things because users can easily manipulate data in the Dataverse. But I want to do this by not using any user accounts because it's an unintended process. And I don't want to give everybody permission to this data or to this table. So what I did is, if you go to the environments, I've got the environment, you've got the Power Platform. It has some information. And I can go to the settings, to the users. And what I've done is I've created an application user, which is a managed identity. So in Azure, I've created a managed identity, which we can check right here. So here I've got my managed identity. It's a user assigned managed identity, which I can use in several different processes. And this user managed identity was added as an application user. So I can actually give it permissions to alter the database and so on. So in this case, you see I was quite lazy and I just gave it the system administrator permissions. If you do this in a production environment, please make sure you use the principle of least privilege. I just wanted it to work for this demo. So let's go back to the presentation. So that's the app user we've looked at and the table. Now, the next part is Azure DevOps. Azure DevOps, it's a system in where we use, where we have the versioning. So developers, they are working on their laptops, on their devices, whatever. They're writing code and they're pushing the code to Azure DevOps. In there, we have the many different branches and people can create the pull requests. But of course, we also need to configure some things there. So one of the first things I had to configure to make it work is something which is called webhooks or service hooks. So in Azure DevOps, you have the option to what they create what they call service hooks. These service hooks, they are things which happen in certain occasions. So you can create one. I've created the webhook version, which will just call a specific URL. And here I can say when it should trigger. So I have many different options. When a build completes, when a release is created, when a work item is created. So you see there's many different situations where you can actually have something happen. If we look at one of these, you see I say when a pull request is created, then in any branch and whatever, so I can also add some filters if I want. I ask it to trigger a specific URL, which we will come back in a moment. If I want, I can give it some more information and it will trigger. Now I've created another one, which at the moment is disabled. That was a test I did before and I left it for now. But at the moment, there's just one pull request. This was when one was updated. I was checking if I could also, for example, have stuff happening when when in a pull request things were updated. But in the end, I decided not to use that. So I just only did one when it's created. And then it's triggering something. Now, there's some more stuff we need to do. One of the things you often want to do is when you have your branches, you want to set up what they call branch policies. And with branch policies, you can make sure that a pull request actually need to be created. There are no branch policies set up in this situation, but if you do set this up in a production environment, you often want to set up some kind of branch policy so people can't push code directly to the main branch, but they actually have to create a pull request. And if they do, you can also set these status checks. So this is what's being used to actually add an extra check in your pull request. This check, we can look at it here. It's called the Power Platform Control. And I can say if it's required or not. And I have some more options. Now, in a moment, we will see how these checks are being created. These checks are being created by calling a specific API. If you're setting this up for the first time, you need to make sure that you've at least once sent some kind of check like this, and then it will show up in the list. Then Azure DevOps will recognize it. This is why you also still see the test state in here. It's what I did when I was developing this solution. I first called it differently, and later I renamed it to the Power Platform Control. But the other one is still in here too. Oh, let's keep it enabled. So that's something we want to set up. And the last thing is that we will need to allow some system to actually also change the statuses of these checks. This is done by using an API. We will look at these APIs in a moment. But to make sure that we can actually assign the right permissions, we need to make sure again that in our users, this managed identity again is added. So I need to actually add this managed identity as a user in my organization. I then can give it the right permissions. So I think we probably have the user here too, and I can give it specific permissions. And I have to add it to the team. Okay. So that's both of the edges we've looked at. So we've looked at the Azure DevOps and the Power App. It's what we've seen before. But now let's dive more into the center. Or sorry, we looked at the Dataverse and the Azure DevOps. But now let's look at actually these logic apps, because this is really where the magic is happening. It's also which caused the most frustration for me to create. So let's go back to Azure. We've got two logic apps here. and I believe it's this one, the new PR. And you've seen that it has been triggered a couple of times. First of all, this logic app doesn't have a system assigned identity, but I did give it the user assigned identity. So the identity I created before, I've added it to this logic app. So this logic app is allowed to actually use this identity. You could do this also with system assigned ones, but then you would need to create different ones for different logic apps, and I had to create multiple logic apps. So this is why I'm using a user assigned identity, so I can spread it out. You could decide to create a different one for every situation to limit the permissions. That's up to you. Now, if we look at the designer, it's a flow with only a couple of steps. First of all, we have the HTTP request. Let's see, can we zoom in a bit more and then move this here so you can actually see it well. This HTTP request is called by the webhook, the service hook in Azure DevOps. So this is the URL we also saw in Azure DevOps. And Azure DevOps sends information to this logic app in a specific way. What I did before is when I was testing it, I just looked at the information it sent and I said, use sample payload to generate a schema. So then I got this schema. And it has a lot of different information about who created the pull request, what is the pull request about, what is the title of the pull request, and so on. So that's all sent to me by Azure DevOps. Now I've created a little delay, and I will explain in a moment why this delay is here. But then the next step is to add a row to the Dataverse. So here is the URL for the Dataverse table. And we're using the API to send some information to it. So I'm using a post request to do this. There is also a connector for the Dataverse, which I will show later. But I wanted to authenticate using a managed identity. So I didn't have to manage all kinds of different service principals or whatsoever. At the moment, at least a couple of months ago when I was creating this, the connector for the Dataverse didn't support managed identities yet. I didn't check before this presentation if it does by now, but it didn't before. So this is why I'm using the REST API. Also because I used to be also kind of a programmer and I like using REST APIs anyways. Now there's one very interesting thing. If you want to use this managed identity, it's actually quite simple. You select the managed identity and which one. But you need to make sure that you set the audience right. And the audience is the name of your organization and then followed by this. If you don't set this, it won't authenticate right. So keep in mind that you set this correctly when trying to do this. In here, you see there's some headers being sent. Make sure you set this accept header, else the Dataverse won't accept it. And then we set the ID and we set the title. In our table, the default value for the approved is false. We can check the column here and see the default choice is set to no. So when it's created, we set the ID and we set the title. This ID is being auto-generated and this is being set to no. So this way it's adding the row to the Dataverse. And then the next thing it's the interesting part. So Azure DevOps has an API to set statuses for pull requests. These are the custom things you can add to a pull request. You can add as many as you want. And you can set which status they are on. And then with the branch policies and the statuses we just looked at, you can say if they're required or not. And this way you can actually control this pull request. This API, it's built up from the name of your repository, the name of your project, and then pull requests, the ID of the pull request, which we got from our initial response, and then statuses, and it's a post. And in here, we set some things. So we set the state, it's being set to pending. We set a description, we set the name. This is the name we eventually have to select in the branch policy. And you also see that we set a target URL. This is the URL of the Power App we were just looking at. So what that means is that if I go to a pull request, I can actually click on this and it will instantly send me to the right Power App. This is done by setting this URL. Again, I wanted to use the managed identity to authenticate. And here is another one. If you want to authenticate with this API, you have to set the audience to specific this GUID. This is documented somewhere on the internet, but it's an interesting struggle to find. So here's my tip to you. Make sure that you use this one because it can lead to some frustrations if you can't find the right one. And the errors it's giving back are not the nicest. And once it's done, I'm sending back a 200 so the service hook knows it's being done correctly. Now, why is this delay being added? It's because here we're actually altering the pull request which is created. Azure DevOps is built on a scalable platform. So I've had it happen that this pull request or this logic app was being triggered. I got my service hook. I was trying to send back this API call and it didn't work. And I got this response that the pull request didn't exist because it was going to a different server and it was still propagating to this server. So this is why I added just a delay of a second. And I haven't had this issue after anymore. So there is other ways of doing it. You could build in a retry or whatsoever. For me, just adding a delay of a second was enough. And this 1 second doesn't really matter. It is technically possible that somebody creates a pull request and in this 1 second then presses the complete button before this status is being added, so it's being enforced. If that is happening, then I think you could also talk with your people that they're probably doing this on purpose. Okay. I think I've covered it all. Yes. So next up, let's take a look at the Power App itself. Because we were just looking at the Power App. So if I'm going to edit this Power App, it's a very simple Power App. Now you can imagine that with this information and this line being added to the Dataverse, I could create a very big Power App. I could add many different business flows in there to eventually, when everything is being done in the app, send back the information to Azure DevOps that it's done. I can actually also update the status while doing it. or I can have multiple different checks being added to the pull request and in the same Power App have them ticked off when they're being done. Just as a proof of concept, I've created this app. It has the approval list. It's connected to the pull request table. The approval list, it just filters out the ones which are on false. And in there, we have the approve button, and the approve button does a patch command to this item and sets approve to true. Once it's set to true, it won't show up in the list anymore because the list only shows the ones which are false. And I also added this refresh button, which does a refresh to the data source to make sure that if you have it open, you can press a refresh. Of course, preferably you just make sure that it doesn't auto refresh or whatever. This is just as a proof of concept. Okay. So we're going to already the last part, which is the second logic app. So the second logic app is the approve PR, which you see also has run a couple of times. Now in here, I've also set up this user assigned identity again. And here I've done something different because here I'm using the trigger when a row is being modified. This is something, a default trigger in the Power Platform. Here I've used a connection, and this connection created a service principal. So this is why in here there's also the Power Apps Checker application, I believe it's called, which is the service principal which was being created. So like I said before, you could create many different service principals. Now do note that there is a limit of application users you can have for a specific environment. But this connection can also be reused. So you could reuse the same connection in many different Power Apps, or sorry, not Power Apps, Logic apps. Now I've created this that it checks the data first table we created, and if there's a update in the pull requests, I'm checking the condition. I could have also added a filter here or in the settings, add a trigger condition to actually only trigger on the right instance, but to show it a bit better, I've created the condition where if approved is true, it will actually do something. So this will only trigger when a line is actually edited, and then for that line, it will trigger it. At the moment, my app only supports the line being edited by setting it to true, and no other edits are possible. So this is for me why it's working. For your system, if you have many different information of other information in this line, you might need to figure out a different way and work with some filters. When it's true, we're calling that same API for statuses again. This time we're taking the pull request ID from the actual data first table. And now I can set the state to succeeded. And when the state is being set to succeeded, it will set the checkbox to true. The same thing, the other things have stayed the same. And in here, we again use the managed identity to send this request. So this way, when it's being run, it will set this one to green, and then we can continue. And that's the whole flow, how it's being built. So if you do this, you enable non-developers to contribute in this developer workflow. Developers like to work in their way of working. They like to work with this pull request setup and so on. So this way you make sure that people who are less used to this way of working still be able to work with it. The use of managed identities and service principals make sure that it is secure, that there's no passwords being used, there's no service accounts or whatever. You can easily scale this up. You can add multiple different checks. If you have multiple departments, you could actually have multiple checks for different departments, give them their own app or build one app for many different departments. And all this results in that you can work better together. With that being said, if there's any questions, now's the time to ask them. Here there's also a QR code for a blog post I wrote about this, which you can find some more information about it. And again, if you want more, find me on the socials or on my website. And I think we've had the first question in the chat already. So, do you want me to read the question or do you want to do it?
I shared the question on the
Yes.
screen.
Okay, so the question is, let's assume I want to merge a new update into the main branch in Azure DevOps, a mini PC onboarded to Azure using Azure Arc and acting as a on-premise server, control a robotic arm. In addition to confirmation via Power Apps, is there a way to communicate via IoT protocols like MQTT or COAAP and require manual confirmation from a robot operator by pressing a physical button before finalizing the code merge for safety reasons? Okay. So a complete physical button is technically possible, but with things like Power Apps, you can also create, like I said, the app for many different teams. So you could create this app also for a robotic operator. If you use something like the Power Apps app for your mobile phone, you can actually create these apps in there. Or with Power Automate, you could have a button flow, which would allow them to say it's okay or not. So that would be a way. Communicating with IoT protocols like MQTT or COAP would be possible because these surface hooks, like I showed, are just sending something to a specific URL. So you could create some kind of Azure function or different system, which would then communicate with these different protocols and sends back a pending request. And only when they get back the right response, it would be okay. And this way, you could also work with a physical button. If you have some kind of small microcontroller, ESP controller, you could create this kind of small button, which as a request is sent to, the button lights up, and only when the button is pushed, it sends the command back that it's okay, and so on. So there is ways of doing this. I hope this answers your question.
Yeah, great, thank you. I think there is no more question in the chat, but guys, if you have any question in the future, you can contact me on the social media, LinkedIn, and you can ask your question from. Okay, great. Thank you, Louis. Thank you, guys, for this session. Have a good day.
Thank you very much.
Bye bye.